In this module, we'll look closer at the syntax, which includes fields, operators, keywords, functions, and the way in which these are structured into clauses. JQL queries need to be well structured to execute at all, and even if they execute, you want to ensure they return the correct results. So let's look at the syntax. Syntax is made up of fields, which can be either system or custom fields, operators, functions, and keywords. Let's cover 3 quick examples and then review each in more depth. In example 1, we have assignee equals jsmith. This query will find all issues assigned to jsmith. Assignee is a field. The equals sign is an operator. jsmith is a value. In example 2, we replace the value jsmith with the function current user. Now, the query finds all issues assigned to the current user. The current user is the user executing this JQL or looking at the results of a saved filter, board, or gadget that uses this underlying JQL. Our third example is assignee is empty. This returns unassigned issues in the whole Jira instance. The operator is different. Here, we use the is operator. And instead of using a value or function, we use a keyword, empty. We could also use the keyword null. This query is the equivalent of the previous one. It means that the assignee field has no value, it has no assignee, or in other words, it is unassigned. Let's step back to look at fields in more detail. We will look at them in logical groupings. A field means either a Jira system field or a custom field that has already been defined in the system. For example, the priority field. There are many fields in Jira. You can query custom fields, either by name, like region, or by the custom field ID number. For example, CF10021. It is not possible to compare 2 fields in JQL. For example, you cannot run a query to show issues where the reporter field is also the assignee by keying in a search such as reporter equals assignee. There are many different data types that can be used with system fields or custom fields. For instance, assignee, creator, and reporter. Date-related fields. Created. Due. Resolved. Updated. Examples of text-related fields. Comment. Description. Summary. And text. Examples of version-related fields. Affected version. And fix version. Link field related. Epic link. And issue link type. And there are many other common fields, like component, labels, priority, resolution, sprint, status, attachments, category, original estimate, project type, watchers. And it's also worth noting that there are fields specific to applications. For example, approvals. And organizations are fields specific to Jira Service Management. Many marketplace apps also come with additional fields that you can use in JQL queries. Let's move on to operators. We will cover all 17 operators in JQL. These operators consist of one or more symbols or words, like is or the symbol for equals. We will discuss these features by putting them in logical groups. We'll then have examples of the fields you would use those operators with. They compare the value of a field to the left of the operator with one or more values or functions to the right of it. Some operators may use the not keyword. The equals operator is used to see if the value of the specified field exactly matches the value provided. You can use the exclamation point with equals to negate the existence of a value match. An example is reporter equals jsmith. This returns all issues where JSmith is in the reporter field. One important thing to keep in mind is that this operator cannot be used with text field types, such as summary or description. That is only possible with the contains operator, which we will cover later. These operators return all issues where the value of the provided field is greater than or equals, less than or equals, that is compared to the value you have provided in your query. Naturally, they can only be used with field types that support ordering, such as date and time, versions, voters, or priorities. The example finds issues where the due date is less than the 15th of October 2018. The tilde character is the contains operator. It can only be used when searching in text fields, such as summary or description. It can perform both exact searches and fuzzy searches, meaning that it returns issues where the value is contained somewhere in the text. For example, if you query summary tilde screen, this will return all issues where the word screen or simple derivatives of it, screens or screening or screened. If you only want to return issues where summary contained specifically the word screening, then you will need to put it in quotation marks, like the example on the bottom. If you query summary tilde full screen, this will return all issues where the individual words full or fullness, for example, and screen or screens, screening or screened, for example, are found in the summary. This might or might not be what you intended. If you query summary tilde / full screen /, this will return all issues where the exact phrase full screen occurs in the summary, as seen in the example on the bottom. The operator is tests for whether a field does or does not have a value, so it is only used with the empty and null keywords. The not operator is used to negate and can only be used with the operators is, was, and in. Here, resolution is not empty returns resolved issues, namely issues which have a resolution value, which is what JIRA considers to be resolved. The operators in and not in test whether the value of a specified field is one of or none of the multiple specified values. Priority, not in, highest high, will find issues where priority is neither highest nor high. These four operators, was not, was in, and was not in, are very powerful and versatile. Was searches through issue histories and enables you to search for past values with the additional possibility of defining a time frame to search within. However, the operators can only be used with these 6 fields: assignee, fixed version, priority, reporter, resolution, and status. And they accept 5 optional predicates: before, after, by, on, and during. Status was in progress by JSmith returns all issues that were or are currently in the status in progress and were set to that status by user JSmith. Similar to the was operator, the changed operator allows you to search through the histories of issues. It can also be used with the same 6 fields, and it accepts 7 optional predicates. These optional predicates are the same ones that are used with was, along with from and to predicates. This allows you to find issues where a specific field has ever changed or has changed within a defined time frame. Assignee changed by JSmith returns all issues where the user, JSmith, has changed the assignee in the past. There are many functions. We will just highlight some of them, grouped together in various categories. A function performs a calculation or gathers information and returns the results to the JQL clause. Several marketplace apps provide even more functions than JIRA does, out of the box. Let's look at functions in more detail. These functions are all sprint related. Open sprints, closed sprints, future sprints. Sprint in open sprints returns issues in all currently active sprints. If there are no other clauses, then it will be all sprints in all teams or projects. Approver, current login, current user, members of, and updated by are user-related functions. Assignee equals members of developers, returns all issues assigned to any user who is in the developers group. Earliest unreleased version, latest released version, unreleased versions, and released versions are functions that are related to releases. Fix version, in released versions, returns issues where the fix version has already been released. And there are many more functions, such as linked issues, standard issue types, subtask issue types, and watched issues. Issue and watched issues. And project equals Mars returns issues you're watching in the Mars project. There are also date and time related functions and functions related to SLAs in service management, but we will cover those in their own sections a bit later. So let's move on to keywords. There are only 6 of them. And or keywords are used to combine multiple clauses. Let's see one example, but we will cover it deeper in a minute. Priority equals high and project equals demo returns all high priority issues which are in the demo project. You already remember not from the operators section. However, it is also a keyword that can be used to negate entire clauses or entire chains of JQL clauses. Not status equals closed or status equals done returns all issues where the status is neither closed nor done. Empty and null. We already know these keywords from the operators section. Equivalent keywords used to search for issues, where a given field does not have a value. Both can only be used with fields that support the is and is not operators. Due is not empty returns issues which have a due date. Order by needs to be placed at the end of a query and manipulates the way the issue results are sorted. It needs to be extended by a field and the sort order. ASC, for ascending, puts the lowest value on top of the list and the highest at the end of the list. DESC, for descending, starts with the highest value and ends with the lowest value. Due less than now, order by assignee DESC, will return issues ordered by assignee in descending Z to A order. This entire construction or fields, operators, and functions is called a clause. This query returns all unassigned issues in all of JIRA across all projects, assuming of course that the user has the right permissions. You can join clauses by using the keywords and or. When you use the and operator, you are narrowing down the list returned by the first clause, so you can think of it as saying, which are also. So we add the second clause, project equals Mars, which finds issues in the Mars project. So this entire JQL query, composed of 2 clauses, finds unassigned issues which are in the Mars project. Now, what if we wanted to add another clause and use the or keyword? Like or issue type equals story. Did you intend to find either unassigned issues in the Mars project or issues which are stories? Or did you intend to find unassigned issues which are either in the Mars project or issues which are stories? And what will JIRA do with this statement? JIRA will execute, and it will evaluate the 2 clauses joined by and first and then evaluate the or clause. The effect is that it will find issues which are either unassigned issues in the Mars project or they are stories. But since the query will execute and it will return some results, it is difficult to know if that was the actual intent of the query. What if you really intended the other choice, namely, find unassigned issues, which are either in the Mars project or they are stories? Currently, as it is written above, JIRA will not return the intended results. To fix this, you should use parentheses around the last 2 clauses. In fact, You should use parentheses even if the intent was the original, because parentheses ensure valid results, improve readability for others, and provide certainty that the right results will get returned. We recommend using them when possible. This is best practice when you start adding more and more clauses, which are increasingly complex and span multiple query lines in advanced search. Such JQL queries containing multiple clauses without parentheses are valid. They will execute successfully. They may or may not return results, but the results may or may not be what you intended. What happens if you try to run this JQL statement? A. Will not execute. B. Execute but return an error. C. Execute but return no results. D. Execute the AND clauses first, then OR. E. Execute the OR clauses first, then AND. D is the correct answer. In this use case, Leo wants to move to a more consistent way of indicating that a story needs more definition. Historically, some members of the team use the summary of the issue, while others add a label, define. This is further complicated by the way the team has referred to the need for definition in the summary field. Sometimes the summary contains the word define, other times definition or expand. Leo needs your help to create a query which will find these issues so he can manage them. If you would like to walk through the use case and review the solution, you can follow it through using the PDF solution guide that we've provided. We need to create one query that returns both sets of issues, searching on the summary field and the labels field. Importantly, we need to restrict the search to issues in the dev project. We'll need to find the correct operator to use with the text field and with the labels field.